So welcome back to National 4, National 5 Chemistry, and we are continuing our set of lessons on chemical formula. And this will be our final lesson on chemical formula, and we will be looking specifically at what we call ionic formula, which is an exclusively National 5 topic. So the aim of this lesson is to understand how to write ionic formula for any compound, whether it contains Roman numerals, it ends in IDE, or if it's a compound that contains any of those parts for which you need to look up the data booklet. So in terms of success criteria, we would hope that you can determine the different charge of elements in a chemical formula and be able to write the ionic formula for different compounds. Ionic formula is the hardest type of formula that you'll be asked for. And you use the same steps as before, but you add in one additional step. So normally it is the SVSDF. However, this time, instead of SVSDF, you're going to insert an I near the start. So it's going to be SIVSDF, standing for symbols, ions, valency, swap, divide, and formula. And that new step is going to ask you to write the ion that will form from the element. So that's going to be a symbol plus a charge. And it is the symbols and charges written in this row that you're going to put in your final formula instead of just the symbols. So here we've got an example of sodium chloride. Sodium has a symbol Na, chlorine has a symbol Cl. It is a chemical. This one ends in the letters IDA, which means we're just going to use our normal periodic table and valency in order to do the valency swap divide part of this. Now when it comes to forming an ion, we need to use what we know about atomic structure and bonding in order for us to know the charges. Sodium is in group 1. When metal atoms become metal ions, they lose electrons. Sodium has 1 electron in its outer shell, and so it's going to lose 1 electron, and that means it's going to gain a positive charge. Chlorine is in group 7. It wants to gain 1 electron. And so when it does so, gains 1 electron, it becomes a negative charge. So we have Na plus and Cl minus. The valency is exactly the same. The valency of an ion is the same as the valency for the atom. It's 1 and 1. And then we just do our normal procedure. We swap. When we swap, we ask ourselves, can we divide to make them smaller? Our answer is no, so we write them again. Now this time for the chemical formula, we're going to be using the ions in the formula. And what we do is we have to put the ions in brackets. So we put the Na plus in bracket and the Cl minus in a bracket. We would write numbers if the numbers at the end were more than 1. But it's Na plus in a bracket and a Cl minus in another bracket. I'm going to do calcium chloride. Calcium is the symbol Ca. Chloride comes from chlorine, which has a symbol Cl. This is a chemical that ends in the letters IDA, which means we're just going to use our normal periodic table and valency in order to do this. Now when it comes to writing the ion, we know that calcium is in group 2. It is a metal, so it's in group 2, it's got 2 electrons in its outer shell. It's going to lose those 2 electrons and form a calcium 2+ ion. Chlorine is in group 7, it has 7 electrons in its outer shell. It wants to gain 1 electron. When it gains that 1 electron, it becomes -1 in charge. Then we use valency as normal. Calcium's in group 2, so it has a valency of 2. Chlorine's in group 7, it has a valency of 1. We swap. We ask ourselves, can we divide to make anything smaller or simpler? And our answer is no. So we've got 1 calcium ion and 2 chloride ions. When it comes to writing the formula, remember for ionic formula, we put the ion in a bracket and write the number after the bracket. So calcium 2 plus in a bracket, there's one of it, so we don't write a number. Chloride, Cl minus in a bracket, there's two of it, so we write the 2 outside of the bracket. Now we've got aluminium nitrate. This is a compound that ends in ATA, so for nitrate, we're going to have to use page 8 of the data booklet. Aluminium has the symbol Al, nitrate has the symbol NO3. When it comes to the ions, well, aluminium is in group 3 and it's a metal, so it loses electrons. It's going to lose its 3 outer electrons to form an Al3+. When it comes to nitrate, well, all you need to do is look at the data booklet on page 8, and nitrate, you're going to write out the ion with its charge, which is NO3 minus. The valency of aluminium is 3, the valency of nitrate is 1. We swap. Can we divide to make things smaller? In this case, we cannot. And so when it comes to writing the formula, we put the ions in brackets. So the Al3 plus in a bracket, there's one of it, so we don't write a number. With the NO3 minus, we put that in a bracket. There are 3 of them, so we put 3 outside that bracket. Now we've got a few examples for you to try. And what we, again, you will need access to a data booklet for you to do it. So have a go and pause in order for you to give yourself time to answer these questions. Hopefully, this is now everyone restarting the video after having tried these examples. We should find that sodium oxide is Na plus in brackets, then a number 2, and then in a new set of brackets, O2 minus. Magnesium hydroxide, it's an Mg2 plus in brackets, then OH minus in another set of brackets with a 2 after the OH minus. Ammonium chloride is going to be NH4 plus in brackets, and then a Cl minus in brackets, because they both have a valency of 1. Calcium phosphide, well, that is Ca2 plus in brackets, then close the brackets, 3, then open brackets for a P3 minus, close brackets, 2. Remember, with phosphide, it's ending in IDE, which means you're using phosphorus from the periodic table. Next one, ammonium sulfate. For this one, you're just using page 8 of the data booklet, and it's NH4 plus, all in brackets, close the brackets, M2, and then open brackets, SO4 2 minus, close brackets. And finally, aluminium hydrogen carbonate. Well, that is Al3 plus, all in brackets, and HCO3 minus in brackets, and then when you close the brackets, a 3. So hopefully you were able to do those. If you did struggle with any of those, make sure that you bring that up whenever you see your teacher. Now we've got a final questions, and this is just a review of kind of all the topics, which formula is correct. So have a go at all 3 of those questions, multiple choice, and then I will reveal the answers. Okay, well, for the first one, magnesium chloride. Magnesium's in group 2, has a valency of 2. Chlorine's in group 7, has a valency of 1. When you swap and divide, you end up with MgCl2. Oh, for magnesium sulfide, the magnesium 4 sulfide, magnesium valency of 4, sulfide a valency of 2. When you swap and divide, you end up with 1 manganese and 2 sulfur, so it's MnS2. And finally, for calcium hydroxide, hydroxide is OH with a valency of 1, and that's on page 8 of the data booklet, and calcium is in group 2 with a valency of 2. When you swap them over, you should end up with Ca, open brackets, OH, close brackets, 2. So that concludes all of the lessons on writing chemical formula, and we concluded this lesson with Ionic Formula, which is an exclusively National 5 topic. And what we will move on to next is balancing chemical equations and calculating the gram formula mass.